one in my generation has ever witnessed a mission to the moon, but that's all about to change. In this video, we are going to go behind the scenes and do a deep dive on how astronauts are training to prepare to go back to the moon over the next few years. I visited the European Space Agency's Astronaut campus in Cologne, Germany, and got exclusive access to their state-of-the-art training facilities. I took a trip to the moon in their futuristic virtual reality simulator, went on a tour of a true-to-scale copy of the ISS with a real astronaut, visited the diving pool where astronauts practice moving in zero gravity, and even got to go inside ESA's new lunar facility where they have recreated the moon's surface here on Earth. This facility is the first of its kind in the entire world, and no one else has been allowed inside. So if you've ever wanted to be an astronaut, this video is for you. When I arrived at the Astronaut Center in Germany, I didn't know what to expect, and I was so blown away by what I saw. The first stop was their extended reality lab. They started this program back in 2015 to help astronauts prepare for missions in space using virtual and augmented reality. And they even let me have a go and take a trip to the moon.
Okay, I don't know if you've tried VR before?
I have a little bit, yeah. Oh, I'm on the moon.
All right, you're on the moon. So this is a 16 by 16 kilometer area of Shackleton crater. And this actually, we didn't just make this up. This is reconstructed from a digital elevation map, basically. So we scanned the moon with the satellites, and yeah, we recreated this. And then for the fine detail, we used Apollo imagery to get it as close to real as possible.
As you heard, I'm exploring Shackleton crater in VR. This is a real impact crater at the lunar South Pole, and this is where the Artemis astronauts will be heading over the next few years. We have never sent humans to the South Pole of the moon before. Here's where the Apollo landing sites were, and it will come with some really interesting problems. One big problem we spoke about was how at the lunar South Pole, the sun never really moves very high above the horizon. This is because the moon is only tilted around 1.5 degrees compared to Earth's 23.5 degrees, and this creates massive, extremely dark shadows. Shadows that can extend many kilometers long, and they are so dark that you could even hide a school bus inside the shadows and have no clue that they're even in there. Shackleton crater specifically has this really interesting topology where the outside of the crater around the rim is essentially always illuminated, while the interior is always in the shadows.
That's crazy. I think I get what you mean though with the shadows, like how you could hide a bus down in here.
Yeah, I mean, you can try and walk a bit into the crater if you want.
Okay.
All right, I can bring up the sun so it's easier.
Okay.
All right, I think you can stop there. And then I will bring down the sun again, just below the horizon. And you see, so basically around you, you don't really see anything.
You can't see anything at all.
Yeah.
I learned something really cool from this experience. If I asked you to imagine yourself on the moon as an astronaut looking back at the Earth and the sun moving throughout the sky over the course of a day, what kind of motion through the sky would you expect the sun and Earth to be doing? Would you expect them to just rise and set like the moon and sun do for us here on Earth?
So you're gonna see the sun rotates around the horizon, which is the motion that it does. You can let go of the lever, which is what it does when you're on the South Pole there. And then the Earth is going to do a bit of a yo-yo figure 8 motion, because basically the moon is always facing with the same side to the Earth. It doesn't really move around the horizon like the sun does. And you also have the eclipses.
Oh, I see, yeah. I totally didn't think about how the Earth would not just also do this, how it would just go up and down.
If you have a close look at the Earth when it goes up,
yeah,
you're going to notice something actually. Let's see if you can tell which side of the Earth is looking at us, actually.
It's upside down.
It is. And why is that?
Because we're on the South Pole and so I'm standing upside down on the moon.
Exactly.
Something we don't think about much is how the moon only has 1/6 of Earth's gravity, and this changes our understanding and intuition for how objects move. So this VR system is great for providing astronauts with that intuition for how everyday objects move in microgravity environments.
You can grab some rocks and try and throw them in lunar gravity.
How much do these rocks weigh? On the moon?
I'm not sure actually. I mean, they weigh 1/6 of what they would weigh here, but
oh my God.
I'm not too certain. But you can see you can throw way farther than you could on Earth.
I feel so... Oh!
Nice, you hit it.
Of course, the astronauts on the moon won't have the freedom that we have here on Earth because they will be just constrained within their spacesuit, and this comes with many challenges.
And I will actually put your spacesuit on. So now if you look at your hands, you have the XEMU suit, which is what they're going to use. And now if you move a bit to the side, you can see yourself. Wave at yourself, wave at us, hello, hello.
There is so much to be said about astronaut suits and spacewalks, but we will dive into that later in this video when we talk with Herve Stevenen, ESA's spacewalk instructor who literally trains all of the European astronauts to get them ready for space. After the VR experience, we went to visit the life-sized replica of the European Columbus lab that's a part of the ISS, and who better to show us around than a real astronaut, Rosemary Coogan. Rosemary is brilliant and actually an astrophysicist. We hear all the time about astronauts who are engineers or pilots, but scientists can be astronauts too. This trip to Europe filming content for you all has been really amazing, and I can't wait to show you more of the experiences over the next few weeks.
For me, space is just this completely fascinating place where galaxies and stars and planets are born. But from a kind of an astronaut point of view, it's also the place we need to go and explore to find out really where we came from, how the Earth came to be, and there's so much you can learn in microgravity that you can't learn on Earth. So this part here is Node 2, and then this is Columbus.
Okay.
And this is kind of the main part of this mock-up, the main event, as it were. But Node 2 is also quite interesting. I mean, I think this is always quite a nice bit to look at because this is a mock-up of a crew quarters. So this is essentially what the bedroom would be like on space. It's a bit like a phone box sort of space.
Is it for one person or multiple people?
One person. Yeah, and the mock-up is not completely high fidelity. So normally you have kind of 1, 2, 3, 4.
I see.
So there's one on each side and 4
because I guess there's
identical crew quarters.
Like one true axis necessarily.
And then this is Columbus. So this is the European module, where all of the European designed or European experiments happen.
Yeah.
And there's each one of kind of these units is called a rack, and within each rack we have various different possibilities for science. So, for example, I mean this is a glove box. So this is a completely sealed environment where an astronaut would carry out an activity in here. Perhaps it contains kind of dangerous chemicals that might need to be contained, or it needs a very specific kind of temperature control, for example. So you'd have kind of biological experiments in this sort of environment, perhaps.
Is this mock-up true to scale? Do you know?
It's a little bit bigger.
That makes it even worse, because I was going to say, from the outside, it looks massive, but when you're in here, like, especially when there's cabling.
Yeah, because each of these racks is taking up the outside space. Is like this,
of course.
What I've heard people say is because we're looking at this in this environment, this is our floor. But actually there's kind of half the space up here we're not really using. So I think the space almost kind of increases.
Sense.
But I think one of the things about being an astronaut that is sometimes a bit of a misconception is you don't actually have to know very much about the science. You know, you are not the scientist, you are facilitating the science.
I found this point to be so interesting because it's true. I mean, astronauts aren't expected to be these geniuses with infinite knowledge about all the different aspects of science. Rather, they are just highly skilled individuals equipped with the tools that make them capable of completing tasks well while within difficult environments. And they develop those tools while they're down here training. So who better to talk to than Herve himself? And Herve is an interesting guy. He runs the Neutral Buoyancy Lab at ESA and has been training astronauts for spacewalks for more than 20 years now. He is the only non-astronaut citizen in the world who has done spacewalk training in NASA's EMU suit and the Russian Orlan suit. And he's just a cool guy.
So my name is Herve Stevenen. I work here at the European Astronaut Center. I work for ESA and I am the ESA spacewalk instructor for the astronauts that have been recruited by the European Space Agency. And welcome to the Neutral Buoyancy Facility, which is this hall with this big water tank, 10 meters deep. And in this water tank, we train the astronauts on what we call the EVA, for extravehicular activity, pre-familiarization program.
So this facility's goal is really just to get the astronauts ready for spacewalks and familiar with the tools they will be using while they're in space.
So then we have the Columbus module here, a full scale of the...
It's true to scale.
True, yeah, and that's the same scale as the real one, the 1-to-1. And you have the external platform over there. Then what we do, we we have to equip the astronaut in a certain configuration.
This is the first step in the training process. They don't dive in the spacesuits here in Germany, but they train with a similar setup before going to Houston to train using the EVA suits in a similar diving pool.
So how do we equip the astronauts to be trained on this simulated spacewalks? So we use first a jacket like that, a buoyancy jacket like for any diver. And this jacket has a purpose to be inflated, deflated by the safety divers to make sure that the astronaut is always neutral buoyant in the water. That's the beauty of the underwater environment, and that's why we do spacewalk training underwater, that when you are neutral buoyant, you can float in the middle of the water like you would be floating in space, at least if you do slow movement. This is where you attach all your tools, all your tethers, all your hooks and so on, and this is in front of the torso. That's exactly the same position that you have in the spacesuit. In the spacesuit, it's plugged into the spacesuit. Here we attach it with a belt. Yeah. So at the end, our astronauts are equipped like this. In addition, we have a backpack simulating the volume, the envelope of the life support system. That's a bit bulky in the back. And this is how they are, floating in the water, like if they would be in space. And the most, one of the key points also that we had are the gloves. So these gloves are just the external part, which is for protection from the heat and the micrometeorite that you can have in space. The real one are with multiple layers inside, and this is completely inflated under pressure. So there is a huge resistance, which we simulate by just putting another glove inside and a kind of T-bar here, which is a palm bar.
The point Herve is making here is that working with these tools is extremely hard when the EVA suit is inflated. You lose so much dexterity, and so here on Earth, they simulate that by using 2 layers of gloves and that palm bar.
Start already to reduce the dexterity. Not as much as in the real spacesuit, but it's already tricky, quite difficult. This is super difficult to grab something when it's pressurized.